Hello students, let us see this problem from IIT-JAM. So in this question, they're asking to calculate the DC gain and the cutoff frequency of this given circuit. Okay, so let us find. So say this the voltage here is V1. Okay, so V1 is applied here. V1 is applied on non-inverting terminal. So the value of V1 will be across this capacitor 1 upon J omega C. Okay, into V input. I'm using this circuit. Okay, I'm applying KVL here. So now this is, I'm calling this as R equal to 1 kilo ohm. So this will be R plus 1 by J omega C. Okay, now if I solve it further, so this will give me 1 upon J omega C into V input R J R omega C plus 1, and this will be J omega C, it will be cancel out, and now you have V1 equals to V input and 1 plus J R omega C. Now they're asking to calculate DC gain. So if I want to calculate V0, okay, so my V0 will be simply 1 plus, if I call this is RF, and I say call this is R1, okay, so this will be 1 plus RF upon R1 into this V1. So my V0 will be, RF value is 10 kilo ohm and is 1 kilo ohm. So 1 plus 10 kilo ohm, 1 kilo ohm into V1. And if I solve it further, this will give me V0 equals to 1 plus 10, okay, 1 plus 10 into V1. And V1 value is V input 1 plus J R omega C. Okay, so from here I can find the gain. So gain will be 11. Okay, so gain is basically V0 upon V input, which is equal to 1 plus 11 upon 1 plus J R omega C. Now they're asking DC gain. DC gains means the gain at frequency 0. Okay, if I put here frequency 0, this omega will become 0. So DC gain. Okay, so DC gain, that is F is equal to 0, will be 11. Okay, and also they're asking in the question, what is the cutoff frequency? So cutoff frequency is the frequency at which the gain is a by root 2 of gain at 0 frequency. Okay, so now I want to find the cutoff frequency. So let us calculate the cutoff frequency. So I have the expression A omega is equal to 11 upon 1 plus, if I put here J omega and 1 by RC, I put as omega C. Okay, so omega C is my cutoff frequency. Omega C is my cutoff frequency. Okay, if omega equals to omega C, okay, if omega equals to omega C, then automatically my gain A omega at omega C will be 1 by root 2 of DC gain. Okay, so 11 is a DC gain, so there will be A DC upon root 2. So omega C is basically your 1 upon RC, and if I calculate the frequency, this will be equal to 1 upon 2 pi RC. So 1 upon 2 pi, R value is given 1 kilo ohm. So I am putting here 1000 ohm, into C value is given 1 by 2 pi microfarad. So 1 upon 2 microfarad, 10 to the power minus 6. So 2 pi cancel, and power 3 cancel, remaining power 3. So your FC will come 1000 hertz, that is 1 kilohertz. Okay, so your DC gain is 11, and the cutoff frequency is your 1 kilohertz. So this is the correct answer for this given question. Thank you very much.